Hello all, we all know about the ARM processor from a very long time, and we use it in our embedded applications, right? Especially the ARM based microcontrollers are a common chips that are seen in embedded applications. So recently Risc-V is into the market, and and is creating lot of buzz, and especially there are some low cost microcontrollers with small applications or small processing power in the market, and lot of people are interested in knowing about it. So we know ARM for many years, right? ARM is a leader in the low power market especially, and it has a rich instruction set, and we have several ARM based microcontrollers available in the market. So where different vendors use the ARM core, its IP, and basically modify it around to come up with their specific products. So ARM has been a very big competitor to 86. Now to ARM, there is a competitor which is Risc-V, so which is slowly gaining traction. So what is this Risc-V? So basically, one thing that we have to remember is whether it is ARM or Risc-V, it is basically the underlying instruction set that matters, which we in short we call ISA. So what is this ISA? ISA is nothing but basically to put it in a simplest form, right? It is a base for all the computations that happen in your chip, whether it be ARM processor or whether it be a Risc-V processor that we are talking here. So we have a hardware, underlying hardware in the chip, right? And then on top of it, hardware is nothing but the CPU, the memory, the IO, and then other digital circuits that are present. And then to interface with them, we have some software. We will have some software, right? So that software is nothing but it could be operating system, it could be device drivers, whatever. So the instruction set architecture is an interface between your hardware and the software. So this is where the ARM and the Risc-V differs. We will talk about this in the coming videos. And then why Risc-V is gaining traction basically. So Risc-V is an open source ISA. That means you can build your controller around that Risc-V as this is open source. Now ARM is a proprietary one, right? So many of the companies buy these proprietary IP and then build their specific controllers, right? So this is where Risc-V is an advantage. But as we have been mentioning, the Risc-V is is in the initial phases of its development, and right now especially focused on the low end processing capabilities. There is lot of projection, and at one point definitely it will be a huge competitor to the ARM processor. Now if we see in the market, we have several microcontrollers that are available, right? Or the application processors. Basically, the cortex-m microcontrollers, cortex-a processors. Basically, we call them SoCs, right? Which are available, which are 32-bit, and we have 16-bit microcontrollers, 8-bit microcontrollers from different vendors. Now, Risc-V, one of the vendor which is very commonly seen these days, which is available at a low cost, CH32V003 chipset, which is the chipset that is available in the market, and lot of engineers are willing to learn the Risc instruction set along with using the microcontroller in their applications. And as we see here in this diagram, this is the chip that we are talking, and then these are the evaluation tools around that chip that are available from one of the manufacturer. So in our videos, right, we will start working on CS32V microcontroller, and we will learn about the features of it and how in the process we'll also see how it differs from the ARM controllers, and how the programming and how the interfacing varies from the ARM based microcontrollers. So please post if you have any questions, or if you have more information on Risc-V ARM related processes, please do post in the comments. Thank you.